Hi guys, in this video I want to introduce you to Euler's Rule. And Euler's Rule is identifying, working out faces, vertices, which is corners or edges within a 3D object. And you can actually work out how many edges there are in a 3D object, or how many vertices or corners in a 3D object, or the number of faces in an object based on having given the other two pieces of information. So we got here F for faces, we have V for vertices, which again, as I said, means corner, okay, and E for edges, okay. And the rule is to work out the number of edges that exist in an object. You would count the number of faces, you would add the number of vertices, and then subtract 2. And you'll find that's the same pattern all along. Okay, so let's put this in action, and we'll start off with, what we know as the cube. Let's see if we can make that a nice cube there. Okay, so that side is the same as that side, which is the same as that side, and in a cube we have 6 faces. Okay, so in a cube we have 6 faces, and if we were to work out the number of corners or vertices, we got 1, 2, 3, 4, then we've got 5, 6, we've got 1 at the back there, 7, and then 8. So what I might do is I might just even dot it there so you can see which ones we're counting. So I got 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay, we're going to take away 2, and that is going to give us the number of edges that we have. So 6 plus 8 is 14. 14 minus 2 is 12. So we got 12 edges. So if we count this, we got 1 edge, 2, 3, 4 edges, 5, 6, 7, 8, and then 9, 10, 11, 12 edges. And so this cube, that will apply to your rectangular prism as well. Okay, so let's say, well, does this apply to, say, a pyramid? So we've got a pyramid here, and let's make it a square. Yeah, it's a bit wonky. Let's make it a triangular prism, triangular pyramid. So, all right. So what we have here, triangular pyramid, and we'll apply the same rule. Okay, so number of faces that we have here is 1, 2, 3 in the front, and then 4 at the bottom. And then we're going to add the number of corners that we see. So we got 1, 2, 3, and then 4 in the corner again. And then we're going to take 2 away, and we're going to find out how many edges we have. So 4 plus 4 is 8. 8 minus 2 is 6. So let's count that. We got 1, 2, 3, 4, 5, 6. 6 edges. Okay. Let's think of a triangular pyramid. Okay, and we're going to count the same thing, and in this case the number of faces, we've got 1, 2, and let's put the dots in. So we got 1, 2 on the ends, and 3, 4, and then 5. So we've got 5 faces in this triangular pyramid. We're going to add the number of vertices. So we've got 1, 2, 3, 4, 5, 6 corners. I'm going to take 2 away to get the number of edges that we need. So 5 plus 6. 5 plus 6 is 11. 11 minus 2 is 9. So we're expecting to have 9 edges. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Okay. I'm going to do one more, but in this case, we're going to work out, I guess, backtrack to work out one of these other two, given that we already know the edges. So let's see how I can succeed in drawing this diagram. So we've got a hexagon and okay, so we got a hexagonal pyramid here, and let's backtrack. We can count the number of edges that we have. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 edges, okay? And I would like to know how many faces there are, but we're going to work out, no, let's work out the number of faces, and we can work out how many corners there is, okay? So we've got 6 triangular faces going around, and plus the base, which is going to be number 7. Okay, so what we have here now is we've got a missing value. Okay, so we've got 7 plus something, and then if we take away 2, we need to equal 12. So if you think about it, what number would it be? Because 7 minus 2 is 5. So 5 plus what gives you 12? We need 7. Okay, so the missing number is 7. 7 plus 7 is 14. 14 minus 2 is 12. We can double check that. We got 1, 2, 3, 4, 5, 6, and 7 corners or vertices. So that's Euler's rule. Let me know if you have any questions. Otherwise, have a great day, and I'll see you in the next video.